Later said, if chlorine can't find a suitable element, she can bind to it herself. But she didn't. She found sodium, and they lived happily ever after. Something like that. You all have beautiful outer shells. How do I get a shell like yours? Yeah. Lane. Fair enough. Okay. Noble gases. The noble gases, of course, live in castles because they're noble. You're not strong enough to take one off me. Remember that guy?
Yeah.
Okay.
Yeah.
So noble gases, they end their configuration P6. They are mostly unreactive because they have a filled octet that gives them near zero electron affinity, very high ionization energies, and that's what you all need to know about noble gases. Now, I say mostly unreactive. Some people just say they are unreactive. Understand that xenon and radon can actually bond when they're attacked by fluorine. So fluorine attacked neon. She can't attack neon. But if she actually would have attacked xenon, she could have actually attacked xenon because she has a high enough electronegativity. But yeah, jack one of those electrons. So we say they are mostly unreactive. Not entirely, but mostly unreactive. Because they have filled. You all have beautiful filled outer shells.
What is the electron?
Yeah.
What happens if there's absolutely no other element that they can
It creates what's called a radical. And radicals don't exist for long because there's almost always something out there. Even in deep space, there's one element per square meter or per cubic meter. So yeah, radicals are when diatomics are alone, but they don't exist for more than a couple nanoseconds. Okay, the rest is trivia, and you don't need to write it down because we need to move on. We have one group left. If you're curious where noble gases come from, they come from the ocean.
Really?
Yeah. They bubble up from the ocean, then we gather up the bubbles.
Wait, you can really? Okay, so you know how the neon signs or whatever, how do they make that happen?
They warm up the tubes. Yeah, exactly. So they warm up a glass tube and they bend it to the shape they want it. Then they pump neon into it. They put a wire in one end and a wire in the other. And you run high voltage through. Electricity goes through the neon and creates a plasma. A plasma is a, guys, we're almost done. A plasma is a gas that is so hot the electrons can travel between atoms.
Do you know if there's any naturally occurring like stuff like that?
The sun.
So it's not, no, I mean on Earth.
Yeah, up in the high atmosphere, when electricity travels through the gas, what you see is a plasma, a very short-term plasma. What you call lightning is a plasma.
What?
Yeah. And lastly, rare earth elements. They have pretty much the same oxidation as the D block, but we're not going to deal with them. Just understand that that's what they do, but we're not going to deal with them. They're very heavy, they're very dense. Most of them are radioactive, almost all of them, in fact. The lanthanides are the top group, these are the 4 Fs, and the actinides are the 5 Fs. So the lanthanides are the 4 Fs up top, and the actinides are the active ones, if you will, which are the 5 Fs down below. And we have a word for everything that is beyond uranium we call transuranium elements. Everything that is beyond uranium is artificial. So, to our knowledge, there is no naturally occurring no naturally occurring elements beyond uranium. Uranium is the heaviest naturally occurring element. And that is where we end.
So all the other elements past uranium, those have all created, right?
Mm-hmm.
What about these undiscovered ones?
Well, they're, you mean unnamed ones? These are elements that we may or may not have discovered. We usually put it on the periodic table when we think we discovered it, but we don't have enough evidence to say we absolutely did. Like livermorium and fluormorium, we just actually added those names because we confirmed that, okay, yep, we discovered them. Did we discover them? Yep, okay, so we give it a name.